Welcome to part 3 of 202F. We're now going to look at the fourth objective, which is calculating the power factor correction using the current method. Our industrial factory is operating at 490 amps with a power factor of 0.68 lag. What we need to do is correct the power factor to 0.9 instead. We start by taking our existing ampacity at our existing power factor angle and using that value to calculate what both our resistive ampacity and our reactive ampacities are going to be. We need both these numbers to do the rest of the process. In order to calculate what my resistive ampacity is, I take my I total at 490 amps and multiply it by the cosine of theta, or the cosine of my operating angle. The result is 332 amps for the resistive ampacity. To calculate what my reactive ampacity is, I take my I total and multiply it by the sine of the angle, which gives me a total reactive ampacity of 359.272 amps. After I have the resistive ampacity and the reactive ampacity of my original load, I now have to figure out what my new I total is going to look like and what my new I reactive is going to look like at my corrected power factor. The only number I can take from one to the other is my resistive ampacity, because that is not going to be affected by the capacitor bank. In order to figure out what my new total ampacity should look like, I take my resistive ampacity and divide it by the cosine of the angle, which gives me a total new ampacity of 370.222 amps, which, if I compare it to my original ampacity, I have nearly 120 amps savings by doing a power factor correction. I continue on by doing my new reactive current, which is IXL is equal to resistive current multiplied by the tan of the angle, which gives me a new reactive current of 161.377 amps. My next step is to figure out what the ampacity of my capacitor bank is going to be. This not only gives me the ampacity to size my wires and my disconnects, but it also gives me an idea of how to get my total reactive power from this calculation. Just like we did before, we need to take what my original value was, and this time it's my original reactive current, subtracted by what my goal reactive current is in order to get the current of my capacitor bank. So in this case, my capacitor bank ampacity is going to be 207.895 amps. My final step is to calculate the kVAR rating of my capacitor. In order to do this, I use my power formula. I will take my applied voltage of 240 volts, multiply it by the ampacity of my capacitor bank at 207.895 amps to get a total kVAR rating of 49.894 kVARs. This is the smallest capacitor bank I can have in order to correct it to 0.9. I can always put in a larger one, but I can't put in anything smaller or else I will not achieve a 0.9 power factor. To summarize, there's 4 simple steps in order to calculate my kVAR rating using the current method. First, I need to find out what my resistive current and my reactive current is at the existing power factor. The next step is to use the resistive current as well as the new power factor in order to calculate what my new total is going to be and my new total reactive current is going to be. Once I have my goal reactive current and my existing reactive current, I subtract the two in order to find my capacitive reactive current. And by taking that capacitive current, multiplying by my source voltage, will give me my kVAR rating for my capacitor bank. You've now reached the end of 202F. Hopefully, after watching these 3 videos, you'll be able to analyze a circuit that has a capacitive load in parallel with a motor and be able to understand the effects that the capacitor has on the new total values. You should also be able to state the reasons for and list the methods of maintaining a high power factor in an industrial plant, as well as be able to calculate the kVAR rating of a capacitor bank using either the power method or the current method. Review these 3 videos as many times as you need to, as well as making sure that you go through your module. Once you've done that, go back to Blackboard. I have another worksheet waiting for you based on power calculations using the current method. After that, do your knowledge check and complete the 202F quiz. Once you've done all this, you can move on to your next theory exam, S1-2.